All right, in this video, we're going to be looking at using the normal distribution. So if I'm looking at a set of data that happens to have a normal distribution, then we're able to use the idea of a normal curve. Now, another phrase that you'll hear to describe what we're talking about today is the idea of a bell curve. So if you look at this diagram right here, you'll notice that our data is basically spread out in a pretty even fashion, where a lot of the data values are kind of in the middle near the mean, and then as you get further away from the mean on the low end and on the high end, you have less and less people. If you want to think about it as like test scores or your grades, most people are going to be somewhere in the middle, B's and C's. It's going to be a few people with F's, and there's going to be a few people with A's, but typically grades are going to be distributed over a bell curve or a normal curve. So areas underneath a normal curve. So first of all, a normal distribution with a mean of x bar and a standard deviation of sigma, or lowercase sigma value, has the following properties. First of all, the total area underneath the curve is going to equal 1, okay? Meaning 100% of my data is going to be somewhere underneath that curve, okay? Now, if I were to then split it all up, we could say that about 68% of the area lies within one standard deviation of the mean. What I mean by that is if I put the mean in the middle of this bell curve, right here, here's x bar, and I were to go one standard deviation to the left, x bar minus one standard deviation, and one standard deviation above, x bar plus one standard deviation, in between those two values, we'd have 68% of our area or 68% of our data values. If we were to extend that 2 standard deviations on either side of the mean, we're looking at about 95% of the area, from 2 less to 2 more. So it's going to be 95% within 2 standard deviations of the mean. And then finally, about 99.7% of the area, basically all of it, is going to be within 3 standard deviations of the mean. You'll notice that on the diagram here. Here's just about all of it, okay? Now, if I were to split that up into the sections on just one side, like let's say I wanted, what percent is just in this region, just within the mean and 1 standard deviation less? Well, that'd be 68 cut in half. So that's going to be 34% in this region right here, and it'd be 34% in this region right here. If I want to know just one of these other smaller ones, well, then you just take 95 minus 68 and cut that in half. For instance, in this region, we've got 13.5%. Right here, we've got 2.35%. And this little guy way at the end, remember, this is beyond 3 standard deviations. So, 99.7 is within that. So 0.3 is left over. Well, 0.3 cut in half is 0.15. So these same percentages, same numbers are going to exist on the other side of my bell curve as well. I'm going to use that to answer some questions down here. So for a randomly selected x value from a normal distribution, find the following probabilities. So what's the probability, that's what P is, that x, some particular data point, is in this region, in between 2 less than the mean to the mean. Now, I've drawn a bell curve here, and I'd suggest you take a moment and do the same. Just draw a quick bell curve, cut it up into regions. It doesn't have to be perfect, but at least that way I can label a couple things. So I know that I'm looking for values that are between, let's see, x bar was the top end, and 2 standard deviations less than that. Well, that'd be right here, x bar minus 2 sigma. So really what we're trying to do is we're going to figure out, well, the probability that x is somewhere in here is going to be, the area or the percentage that will exist in these 2 regions. So I go up above and check my diagram. I've got 34% in this region, 13.5% in this region. I add those two together. My probability is going to be 0.475 if I want it as a decimal, or 47.5%. Okay, I'll put 0.475 just in case we want decimals. Probability is often referred to as a decimal. Sometimes you can get away with percent. Either is going to be okay. One more example. This probability that x is in between 1 standard deviation less and 3 standard deviations greater. Well, here's the mean again. Here's 1 to the left. Let's shade this in quick. And then we're looking at that region, and this region, and this region, or at 2, and this region, all the way out to x plus 3. This is 1, 2, 3 standard deviations away. Add these up. Let's see, 34 plus 34 is going to be 68. Plus another 13.5, plus another 2.35%. Our total there is going to be 0.8385. or if you want it as a percentage, you're looking at 83.85%. Either of those numbers would be just fine. So we'll take those numbers and apply them to some actual data values in the next video.